All right, we're going to be taking a look at 3.4.2. This is just a continuation of 3.4. We'll do a couple problem-solving systems, one with graphing, one with substitution, just as a refresher, and then we will work on solving using elimination. So in our first system of equations, we have two lines given to us in slope-intercept form. So that's y equals mx plus b. So I have a red line here. I also have a blue line here. So I'm going to write down my information. So from my red line, my m value is negative 1 over 1. That came from the value that's next to x. So that would count down 1, right 1. And my b value is negative 4. Y equals mx plus b. For my blue line, my m value is 4 over 3, and my b value is 3. So again, mx plus b. I'll go ahead and graph my red line first. I'm going to begin at negative 4, and then I'm counting down 1, right 1. I can also do, so down 1, right 1, I can also do the exact opposite. I can go up 1, left 1. So if I were to go up and left, I would get points here. I'm just going to count up and left all the way across my graph so that I have some clear points across my whole graph. Okay. Graph my line, and now I can work on my blue line. So for my blue line, I'm going to begin at positive 3, and I am counting up for right 3. So those are my directions. If I can't do that, I'm going to do the exact opposite. I can count down for left 3. So let's see. If I can't go up for right 3, so I'm going to count down for 1, 2, 3, 4, and left 1, 2, 3. And you'll see I have a point right here. So I'll draw a line through my points as close as I can, which is why it's important to use actual points. Red and blue make purple, so that my points crossed right here. So we can describe our answer as an x and y coordinates. Negative 3, negative 1 are the coordinates for that point. So that's solving using graphing. Solving using substitution, when we have one equation that is solved for and one that is in standard form, we can replace the value that we have for our variable that is solved for into the other equation for that variable. So we have 5x minus 4, and then I'm replacing y with 6x minus 20 equals 23. We are going to distribute first, so negative 4 times 6x is negative 24x. Negative 4 times negative 20 is going to give us positive 80. I'll rewrite my 5x and my equals 23. Those didn't change. Now I'm going to combine like terms. So I'm going to combine my 5x and my negative 24x to get negative 19x plus 80 equals 23. I have a two-step equation I'm solving. My first step is to subtract 80 from both sides. And we're going to do 23 minus 80 to get negative 57. So I'm going to have negative 19x equals negative 57. And then I'm dividing negative 19 to both sides to find the x equals 57. Negative 57 divided by negative 19 is going to give us a positive 3. X equals positive 3. Now that we know what x equals, we can substitute this for x in either of our equations. We can choose either one, but the one where y is already solved for is going to work out a little bit cleaner. So I'm going to say y equals 6, and then instead of x, I'm putting a 3. And that's not 63, that is 6 times 3. So when we work that out, that's 18 minus 20, which means y is equal to negative 2. So our solution as an ordered pair is x, comma, y. 3, comma, negative 2. For number 3, we're going to solve using substitution. I'm looking for exact opposites. I can change my equation if I need to. My x's, in order to get exact opposites, I would have to multiply my entire bottom equation by a negative, or a negative 1 to switch all the signs to get rid of my x's. However, my y's are already exact opposites. So when I'm looking at my y's, I don't need to change anything. So I can put these together in red and get negative 10x. I'm just counting them up. So a negative 5x, negative 5, following my sign rules. When I put my positive 2y and negative 2y together, they cancel out. And negative 19 and positive 9 will give me a negative 10. So essentially I'm left with negative 10x equals negative 10. I can divide negative 10 to both sides to get x by itself, and that's going to be 1. So x equals 1. I can now use that in either of my equations to solve for y. I'm going to use the top equation. So I'm going to do it for the top equation. And I'm replacing x. So I'm going to have negative 5 times 1, that was my x value, plus 2y equals negative 19. When I multiply these together, I get negative 5 plus 2y equals negative 19. And now I have a two-step equation. I'm going to get rid of my 5 first by adding it to both sides, so that 2y equals negative 14. I can now divide 2 to both sides, so that y equals negative 7. And then I'll write them as an ordered pair, 1, comma, negative 7. For number 4, we're working with elimination. I have common leading coefficients here with 4s. The problem is that these will not eliminate each other. So I'm going to look over here. I don't have common coefficients here, so I would have to change both of these equations. But this one, I have common coefficients of 4. The problem is that I need 1 to be positive and 1 to be negative. So I'm going to create that by scaling my equation. I'm going to multiply a negative 1 to everything. So negative 1 times negative 4 is positive 4x. Negative 1 times positive 8y is negative 8y. And negative 1 times 8 is negative 8. My top equation, I'm just going to rewrite negative 4x plus 7y equals 4. Now I have exact opposite values that will eliminate, so I can go through and I'm going to put negative 4x and positive 4x together to cancel out. I can put a positive 7y and a negative 8y would make negative 1y. And a positive 4 and a negative 8 is going to give me a negative 4. In order to get y by itself, I'm going to need to divide that negative 1 to cancel it out to make it positive 1y. And negative 4 divided by negative 1 is positive 4. So now that I've solved for y, I can go back and solve for x. I can choose this equation, this equation, this equation, this. Whatever you have there, you can use. I don't really like to use the ones that I rewrote just in case I miss a sign or something like that. So I like to try and use my given equations. And I'm going to go ahead and just choose this top equation here. So I'm going to say negative 4x plus 7, and then I'm replacing the y. We always want to pay attention to which term we are substituting. So I'm replacing the y with a 4 equals 4. And now I'm going to work these out. So I'm going to do 7 times 4 to make 28. Rewrite everything. Now I have a two-step equation, so I can subtract 28 from both sides to get negative 4x equals negative 24. I can now divide negative 4 to both sides, get those to cancel out, and x is equal to 6. So, as an ordered pair, we would write this x, comma, y. 6, comma, 4. All right. Number 5. With these ones, and this is really the bulk of, so this was 1 through 4 were kind of like warm-up problems. Number 5 is what we're working on in 3.4. So we're going to take a look at our problems, and we will notice that we don't have common values for our coefficients, common numbers on our variables. So we need to create that. We need to create that in order for them to eliminate. And so I do have a 1x here. I'm going to write that in so that we see it. And really I'm looking for, can my smaller number be turned into my bigger number? Could I multiply something to my smaller number to make it, to turn it into my bigger number? For my x, I could multiply this by 3 and it would turn it into that. For my y, I wouldn't be able to multiply anything to 3 to turn it into a 4, not a whole number anyways. So I'm going to multiply my whole bottom equation by 3, and I'm going to need to make this negative 3. So there, I'm going to make that a negative 3 that I'm multiplying by. So I'm going to say negative 3 times 1x, which will give us negative 3x. Negative 3 times negative 3y, which will give me positive 9y. And negative 3 times 8, which will give me negative 24. For my top equation, I don't have to change anything. So I'm going to have 3x plus 4y equals negative 2. Now that we've scaled our equation, we have terms that will cancel out. I can put 4y and 9y together to get 13y. And I can put negative 2 and negative 24 together to get negative 26. I'll divide 13 from both sides to get y by itself. And y will equal negative 2. Now that I've figured that out, I can go back and plug it in. I'm going to plug it in for my bottom equation here for this one. So I'm going to say x minus 3, and then I'm replacing y with a negative 2, so that's a negative 3 times a negative 2 equals 8. So let's see here. We have a negative 3 times a negative 2, which is going to give me a positive 6. So I get x plus 6 equals 8. And then I'm subtracting 6 from both sides. And I'm getting x equals 2. So my solution to this system of equations is my x value, comma, my y value, 2, comma, 2, negative 2. All right. Number 6. I'm looking at my x values. 2 and 6 do not match. 3 and 4 do not match. So I'm going to have to scale an equation. Can I turn a 2 into a 6 using multiplication? And the answer is yes. 2 times 3 would make 6. Could I turn a 3 into a 4? No, I couldn't. So I can't get rid of the y's by just scaling one equation, but I can get rid of my x's. If I scale this equation by a 3, and it would have to be a negative 3 in order to give me a positive 6 here. Negative 3 times negative 2 would give me a positive 6, which would cancel out with my negative 6. So that's what we're trying to create. So we're going to scale this equation. We're going to multiply negative 3 to negative 2x to get positive 6x. Negative 3 times negative 4y will give me positive 12y. And negative 3 times negative 16, signs are the same, so we're going get positive, and we're going to get positive 48. For my top equation, nothing needs to change. So I have negative 6x minus 3y equals negative 12. We do all of that work so that we create this scenario here where I have negative 6 and positive 6x that can cancel each other out. I'll put negative 3y and positive 12y together to get 9y. And I'm putting negative 12 and positive 48 together. That's 48 minus 12, which is going to leave me with 36. I can now divide 9 to both sides so that y is by itself. Y equals 4. Now that we know what y equals, we can go back and solve for x. I'm going to use the top equation, negative 6x minus 3 times 4 equals negative 12. So when I work this out, I have negative 6x, and then negative 3 times 4 is negative 12 equals negative 12. I have a two-step equation. I'm going to add 12 to both sides first, so that negative 6x equals 0. Those cancel out, and negative 12 make 0. And then I am dividing negative 6 to both sides to find x equals 0. 0 divided by negative 6 is 0. So for this one, my x value is 0, my y value is 4. All right, the last couple. We can scale. If we multiply a negative 3 up here, that would make positive 3x, which would cancel out with that negative 3x. If I multiply a 5 to this y, that would give me a negative 5y to cancel out with that positive 5y. I wouldn't have to do a sign. So I'm going to multiply my top equation this time. I'm going to multiply it by 5. 5 times negative x, negative 5x. 5 times negative y, negative 5y. 5 times 9, 45. For my bottom equation, I have negative 3x plus 5y equals negative 13. The whole point is to create either x or y terms that will eliminate. In this case, my y terms are going to eliminate. So I can put these two together in red and get negative 8x. I can put these two together and get 0. They cancel each other out. And I can put 45 and negative 13 together. We're going to subtract that to get 32. Negative 8x equals 32. Now that I have one variable, I can start solving for it. Negative 8 is multiplying with x, so we do the inverse operation. We divide, and we're going to find that x equals negative 4. Now that we know what x equals, we can go back and solve for y. I'm going to use my bottom equation. So I'm going to say negative 3 times negative 4. I'm replacing for x this time, plus 5y equals negative 13. I'm going to multiply my negative 3 and negative 4 together to get 12 plus 5y equals negative 13. And then I am subtracting 12 from both sides to find that 5y equals negative 25 when I put those together. And then I am dividing 5 to both sides to find that y is equal to negative 5. So we found that x was negative 4 and y was negative 5. All right, and then our last problem. So for this one, I can either scale this x to be a negative 2. If I multiply negative 2 down here to the bottom, that will cancel out with that positive 2x. I can also scale this to y. I could multiply it by 3 to make it positive 6y, which would cancel out with negative 6y. So that's what I'm going to do. I'm going to multiply my whole top equation by 3. 3 times 2x is 6x. 3 times 2y is 6y. And 3 times 8 is 24. My bottom equation I'm going to leave how it is. So I have x minus 6y equals 11. And then I'm combining my equations vertically. So I'm going to put 6x and 1x together to get 7x. I'm putting positive 6y and negative 6y together to cancel out, to eliminate. That's why it's called elimination. And I'm putting 24 and 11 together to get 35. And let's not forget my equal sign. So 7x equals 35, which means when we divide 7 to both sides, x is equal to 5. Now that we know what x is, we can plug it into any equation and figure out what y is. I'm going to plug it into my bottom equation. So I'm going to, instead of x, I'm going to replace that with 5 minus 6y equals 11. There's nothing to multiply, so I'm just going to start solving my two-step equation. My first step is to get rid of my term that adds or subtracts in relation to y, which would be this 5. So negative 6y is equal to 11 minus 5, which is 6. And then I am dividing negative 6 to both sides. And y is equal to negative 1. And then we will write our answer as an ordered pair, 5, negative 1.